Yes, I have joined. Yashita.
So let's start with the session.
Okay.
Hello everyone, a very good morning to all of you. Dear authors and invited guests, a very warm welcome to the technical session 11C. Myself Yashita, and I'll be your moderator for this session. So, I'll be making sure that everything runs smoothly. So, on behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, which is ICTIS. The 11th edition of the conference is being organized in a hybrid mode. So, the physical event was held yesterday in Bangkok, while the virtual sessions are being conducted via Zoom from 9th to 11th April, where people from all over world are present with us. So, I hope that you'll enjoy today's insightful and knowledgeable session. So in this session we will be having total 10 presentations with one extra, I guess, because in the last session we were short of time. So each presenter will be given 10 minutes for presentation, followed by 2 minutes for question and answers. So strictly I'm stating now that you have to complete your presentation in between 8 to 9 minutes, and the rest of the time will be given for question and answers by the session chair. So I will give a reminder at the 8-minute mark to help everyone stay on track. Also, a small request to all the participants that please stay connected with us till the closing remarks. We promise that it will be worth it. If you have any queries or updates, feel free to drop them in the chat box anytime. Me and my co-host will address them. So before we begin, I would like to introduce to our esteemed session chair, Dr. Ganesh Pise. Welcome to the session, sir.
Thank you, madam. Thank you.
He is an assistant professor, assistant head research. He's an assistant professor of Department of Information Technology in Vishwakarma Institute of Technology, Pune. So his areas of expertise are include artificial intelligence, machine learning, and Internet of Things. He continues to contribute to academic excellence and technological advancement through teaching, research, and innovation. So when will be our second session chair joining, I'll introduce everybody to her. So we'll be beginning with our presentations. So okay, so first we have Nagesh Sharma. Nagesh sir, are you present?
Yes, yes.
Yes, so your
Hello.
issue is resolved now.
Yeah, yeah.
Yeah, so you can start presenting. And you have to wrap it up quickly as you have gotten many chances. So you have to
I
wrap.
hope my screen is visible right now.
Yes.
So, hello everyone. I would like to present my review paper here, Advances in Clone Attack Detection on Social Media Platforms. And basically, in the global transformation, social media platforms like Facebook, Twitter, and Instagram have like literally revolutionized global communication, and it is really important to take care of that and take care of the all the security matters on that social media platforms, because daily interactions sharing in that particular social media platforms, daily interaction sharing personal and professional information are very common. So there must be many cybersecurity threats also. So growth has increased vulnerabilities, including clone attacks where fake profiles mimic real users. So this particular review we have done of the papers, and we have curated some of the review paper so that we could review the development of AI/ML and different techniques on the clone detection in the social media platform. So we have done this review paper. So the problem statement is the challenges, the problem statement that these research papers have covered, that the clone attacks are increasing rapidly as attackers exploit trust between users. So manual detection is impossible due to large users base and similar looking profiles, right? So the main solution which is needed is to automate an intelligent detecting system using advanced AI techniques. So, what are basically clone attacks? Clone attacks are basically a attacker copies the profile information from real users, and it creates a fake account, which basically establishes the duplicate profile with the stolen identity, from which it tends to gain trust and send friend requests and builds credibility. And from that, malicious acts also happens, it performs phishing, fraud, and misinformation. For example, Facebook profiles impersonating a real person to steal information, right? So impact of clone attacks are basically identify the threat, okay, stolen personal information, credentials, financial fraud, phishing attacks, spread misinformation, loss of trust, platform damage. So from the financial fraud, it is unauthorized transactions and monetary loss, and phishing attacks is malicious links and data harvesting, and for the loss of trust, users lose confidence in platform security. Basically, there are many like negative effects of the clone attacks that we have to deal with. So, the evaluation of detection techniques throughout the years are like earlier methods were basically manually verify and report the users about the clone attacks. But the problem is it is very slow and not scalable at all and prone to human errors. So the modern approach is, with the development of the industry and with the development of technological evolution, we are tend to towards the machine learning and deep learning techniques that we have reviewed. So the one of the common algorithms that are used on this in this type of field are super vector machines, decision trees, and random forest, like the basic ML algorithms, which learn patterns from data and detect anomalies in the user behavior. So, it is basically the anomaly detection that we are dealing with, like the authors dealt with in previous years in the clone attack detection. So the ML advantages and limitations are like advantages are, of course, it is very fast, efficient, and works well with structured data, and less computational cost regarding the basic ML algorithms. But the limitation is that it requires intensive feature engineering. We have to like pre-process the data set and etc. And it is less effective with the complex and unstructured data. We have to convert to the structured data, then we will be able to apply the ML algorithms. So deep learning is also a subset of machine learning. Like, of course, it uses neural networks that automatically extract features from raw data. And in the deep learning field, in the clone attack detection, CNN, RNN, and transformers are the basic models that are used by the authors. So, what are the deep learning advantages here? Is it generated high accuracy like 98%, and it also handles the complex data like text, images, behavior, and it learns automatically without manual feature engineering. Limitations are, to train the deep learning model, we require a large data set, and to train a deep learning model with the large data set, we require high computational cost. So, categories of detection techniques that are dealt with in clone detection are graph-based, deep learning, hybrid, and classification. So in the graph-based approaches, how it works is basically it represents users as nodes and connections as edges to detect the suspicious pattern in network. So advantage are it is scalable for large networks and effective pattern detection. But the limitations are it requires complex feature extraction processes. In the deep learning models, hybrid models like CNN plus STM, transformers, and of course, as I said, the performance are like enhanced very much, like around 98.2%. So hybrid models are also used, as we have discussed, CNN plus LSTM architecture, GAN based models that are generative AI based models. Uh, so generative augmented neural networks are also used. So the key benefits are a robust against attacks with balanced performance across diverse scenarios. So uh, these are the classification algorithm that are also used that we reviewed in the papers. like naive-Bayes, KNN, and assemble models. If we compare, 96% scalable performance was achieved by graph-based models, 98% accuracy was achieved by deep learning models, 95% was achieved by hybrid, and 97% of assemble. So no, basically single method is perfect for all scenarios. In this data sets used to study, like authors use this type of data set, like the basic Twitter data set, Facebook data set, ISOT data set, synthetic data. So they basically web scrape the data from Twitter, Facebook, and various social media platforms. So the challenges that we have observed are like the data set diversity. It is limited variety in available training data.
Sorry to interrupt you, Nagesh. You'll have to wrap up within 1 minute.
Yeah, sure, sure. And the real-time scalability, processing speed requirements for live detection, and privacy issues, data protection and user confidentiality concerns, and of course the adversarial attacks, malicious attempts to evade the detection systems. So the future directions that we could go is the cross-platform models, explainable AI, federated learning, adversarial training. In like this paper is the basic review paper that we have curated. We have done the review of the existing work, and it basically gives the direction to the future work that we would implement. It is not the implemented work; it is the review paper that we have done, right? So we will trend to apply federated learning, explainable AI, and latest generative AI techniques too. So in conclusion, clone attacks presents a serious cybersecurity threat, and machine learning and deep learning significantly improve detection capabilities. But current challenges require ongoing research and innovation, and apply the different latest technology on the clone attacks. The future research priorities that we uh, propose are like enhanced scalability, more robust systems, strong privacy protection, and real-time detection. So thank you for my presentation.
Okay, PC sir, any questions?
Nagesh, can you go to the slide number 15, which is regarding to the classification?
Right. So,
15,
yeah.
slide number 15. Yeah, for what purpose this algorithm you have used? Because you have
Like
considered
the
the social media data
Yeah. So
for Facebook
actually,
and all.
these classification, yeah, I have specified like in the starting of the presentation only. These classification algorithms are basic. These are the common classification algorithms that are used by the authors in the clone attack fields to classify the clone attacks, to classify the anomaly detection. So the data set is like, for example, we take the Twitter data set, Facebook data set, and we have there are classes, certain classes that are some classes are considered as the clones. So these basic classification algorithms that are applied for the clone classification, right? So these are
In
the
your
like the only.
research, in your research,
Sorry.
what is the role of this algorithm? You
So
say that previously it is used.
this is the review paper. We have done the review of the, like, it is a survey, basic survey paper, right? Like
Okay,
these are
means
the
this classification is used in previous research.
yes, yes, exactly, sir.
Why then why you added this slide here? It is expected
To
that it should be in a review.
No,
Okay,
this
anyway,
to
anyway,
specify
Nagesh,
these are,
yeah.
sorry, to specify
Anyway,
that these are the three top classification algorithms that are used in previous work. So if
okay,
we
okay,
future authors, yeah,
got it, Max. What is mean by ensemble?
ensemble learning is basically combining various machine learning models and apply to a particular data set to enhance the performance.
Okay, okay, nice
Yeah,
presentation. Ishita, hand over to you.
thank you.
Yes. Thank you, Nagesh, for presenting. So, next
Yeah.
presenter is Rupali Vairagde. Are you there in the meeting? Okay, let me check once. Okay, she is not present in the meeting. So let's move on to the next presenter. So up next we have Sho Jakon Kamdamov. Are you present? Okay, he is also not present. Matjere Matsebe, are you present?
Yes, I am. Yes, I
Yes, so
am.
he is here to present his work titled as Explainable AI for Automated Risk Assessment in Phishing Email Detection. So you can start sharing your screen.
Yeah.
Yeah.
It's visible to you, right?
Yes, it is visible. You can start. Completed
Okay.
within 8 minutes. Yeah, 8 to 9
Oh,
minutes. Yeah.
okay.
Yeah.
So, let's go through it. So, I'm Matero Matseba, and I'll be presenting our paper of Explainable AI for Automated Risk Assessment in Phishing Email Detection. So, I've wrote this paper alongside my co-author, Dr. Nobubele Shozi. So our agenda includes the introduction, problem statement, research questions, research objectives, and further along up until the conclusion. So for our introduction, so email is a very critical communication tool used by many organizations and has been proven to be highly vulnerable to phishing attacks. So traditional detection methods often fail against this sophisticated phishing attacks, of which AI is used to detect these phishing emails, but the decisions that are made are usually black box. So the background that we completed involved investigating the already existing traditional methods, including SVM, naive Bayes, and random forest, amongst others. So these traditional machine learning algorithms actually used URLs, sender metadata, and message content to actually do their classifications. They were proven to struggle with sophisticated phishing emails, of which may result in false positives or false negatives. Further along, we also investigated the explainable AI techniques, including LIME, SHARP, and EBM, of which provided feature level explanations. Despite their interpretability, we noticed that there's still an existing gap in which a transparency framework needs to be developed to mitigate this risk. So our problem statement deals with the fact that the detection algorithms actually deal with these classifications as a black box, actually preventing users from understanding how the classifications were made. So this lack of transparency often results in users not being able to respond to misclassified emails, and thereof there is a need for an intelligent, transparent system that can perform these assessments. Our research questions involved the fact that how can we develop an AI that is transparent in phishing email classifications? And our sub questions were that which AI models will then perform best in phishing detection? And how would we integrate explainability and confidence into the model? Furthermore, how would we then evaluate the accuracy and transparency of this developed framework? So our objectives were to establish the transparency of AI decision models, to classify malicious emails using previously established work. And our sub-research objectives were to investigate the current state-of-the-art models for phishing detection, develop a transparency framework for risk assessment, and then evaluate that model and framework for effectiveness and user understandable explanations. So a methodology involved the planning, which included literature review and dataset curation. Secondly, model selection, which involved data processing and feature engineering along the line with development and actually building the actual transparency stack and the evaluation of the accuracy and interpretability thereof. So our feature engineering included security-focused patterns, which involved agency, action commands, impersonation, and financial lures. We also incorporated TF-IDF vectorization with a feature limit of 1,500. Structural features were also incorporated, including the text length, punctuation, and capitalization ratios, as well as the behavioral indicators involving URL counts, email frequency, and word counters. So in our investigation, in investigating the best performing model, we investigated logistic regression, SGD, SVM, random forest, and XGBoost. And these models were evaluated with the metrics of accuracy, precision, recall, F1 score, calibration error, and ranking score. So alongside this investigation, it was discovered that the XGBoost is actually the best performer with an F1 score of 0.8757. So the transparency stack involved three bands, which would be the baseline and the banded and the stack, which is the actual transparency stack. So the baseline is the pure model without any other extra features, whereas the banded model is the baseline model with just the risk band incorporated, where the stack, the transparency stack has all features, including the calibrated confidence scores, the risk bands, the conformal prediction for uncertainty, the out of distribution detection, and feature level explanations. So the moderate risk band was actually our key focus area in which it should handle ambiguous emails where the AI has low confidence in its classifications. So this moderate band routes potential false negatives and false positives to the moderate band to encourage user and AI collaboration. So the metrics, as you've seen before, the standard metrics involved accuracy, precision, recall, and F1 score, whereas the transparency metrics involve the calibration error and the ranking score. On the figure to your right, you'll see that in the transparency stack, the calibration error was able to be improved from 0.039 to 0.012 without actually compromising the accuracy and the F1 score. So on this slide, you'll see the system architecture and UI, where the user would upload the email that they want to access, and they'll be given the risk. And to the right, the explanation of the classification will be given, involving the feature level explanations, the bands and calibration score, and the out of detection score, as well as the confidence score. Our results prove that the transparency stack as well as the XGBoost had a 0.8757 F1 score with calibration error reduced from 0.0393 to 0.012. The moderate band reduced unnecessary user intervention while the confidence scores aligned closely with true probabilities. Our limitations involved that our F1 score was below 95% and seen in previous studies, and this study requires an updated dataset to keep abroad with evolving phishing tactics. The moderate band still depends on the user's decision and still requires continuous feature engineering for evolving threats. Our future work will focus on enhancing the baseline model's F1 score for better classifications to above 95%, and continuous learning will be incorporated to actually deal with new phishing tactics. We will also evaluate actual user decision improvements via a field study to assess the impact of this transparency framework. Our conclusion was that the XAI enables transparent, trustworthy phishing detection, while confidence scores and the risk bands improved user engagement. So our transparency stack would work well in integrating AI with practical human-centered design. Thank you. Any questions would
Nice
be
presentation. Can you go to slide number 9, which is regarding to the features?
slide number 9. Yes.
Yeah. Now here you have mentioned the TF IDF vectorization with 1500 feature limits. Can you justify it?
So the justification would be the fact that we have tried with different, I have experimented with different limits, and the sweet spot was found to be around the range of 1.3 to 1,700. So going further than that actually compromised the performance of the model.
Okay. Okay, good.
Okay,
Uh,
thank you so much. Yeah,
nice.
do you have more questions?
No, no, no. Nice.
All right. Thank you so much.
Okay, so I am not able to pronounce this name. So, Mr. Ogli, are you present in the meeting?
Hello.
Hello, you can start your presentation, sir.
Yes.
Am I audible?
Yeah.
Yes,
Yes.
yes, you are audible, Ish.
You can start, sir, your presentation.
Okay, Mrs.
I'll stop sharing my screen. Yeah.
Mhm. Okay. Showing my presentation.
Yes, it is visible. You can start.
Mm. Good morning or good afternoon, Mr. or Miss Misters. My presentation is grammatical postdating outlets the units of Uzbek language, adjective and noun verb clauses. Introduction. So postdating part of speech. Postdating is a key task in the field of natural language processing, which involves automatically analyzed by text assignment the grammatical role of each word. Part part of taking part of speech taking helps to identify morphological and semantic features of a language when I analyze it, and it is visible used in many areas of linguistics and computer science. So using the method of grammatical tagging is possible to develop a clearly understanding of the contents of the text. Automatic translation of text, sentiment analysis, and many other applications. Post tagging is the task of the assigning each word's form in a given sentence to a clauses. For example, noun, verb, adjective, nouns, verb, and pronoun. Post-tagging is one of the main tasks of NLP and is an important stage on this pipeline. Post-tagging in agglutinative language. Agglutinative language such as the Turkish and Finnish exhibited rich morphological structures characterized by extensive suffixation and complex word formation processes. In Turkish, post-tagging systems are really heavily of morphological analyzers to process long suffix trends, while finding tagging models addresses challenges related to case marking, compounding, and morphophonic alternatives. Uzbek language shares similar agglutinative properties, particularly in suffix stacking and derivational morphology. However, compared to Turkish and Finnish, Uzbek remaining a relatively low-resource language with limited annotated proper and computational tools. Therefore, rule-based text construction plays a crucial role is establishing and structural grammatical foundation for sequencing sequenced statistical and neural language NLP models. The comparison highlights that while agglutinative language shares structural complexity, Uzbek post-tagging faces additional challenges due to limited linguistics versus and standardized corpora. Methodology. This study develops a agglutinative post-tagging framework for the adjective and number words class in the Uzbek language based on both linguistics and computational approach. The methodology consists of three main stages. First, text set design. Second, morphological modeling. And Last one, development of the post-tagging algorithms. The proposed model is grounded in a role-based approach and takes into account the alternative nature and structural heritage of the Uzbek language. In particular, suffix-based rules plays a crucial role in identifying the internal grammatical categories of the adjective and numerals, including degree, structural type, durational forms, noun-type classification, and related morphological features. In the study, an extended linguistics concept was development for the adjective and numeral word clauses. The following principles were adopted in the design of the dataset. First, morphological price list, characteristical structure, comparative with UD, universal dependency. Adjective words classified according to the following main criteria. First, according to the nature of the attributes, quality, relative. And second, semantic domain, physical, economic, temperature, color, tests, and etc. Degree, compositive, positive, comparative, declarative. Second one, structured forms, simple, compound, pair, and derivation, based or derived. Following is the example. So adjectives can have different degrees of graduation. So simple adjectives such as a good, yaxshi for Uzbek language, keen, yaxshi. Comparative adjectives are extracted by suffix such as for Uzbek language rock, for English well. Superlative adjectives were usually formed with intensively such as in nihayat tajwida, for example, English the best. The gradation of adjectives, especially in the comparative and declarative forms, plays an important role in ensuring the accuracy of the post system, since in such cases of contextual analysis of the adjective necessary. For example, the following. This table illustrated of lexical grammatical texts of the adjective words in Uzbek. So the table text of the numeral in words in the Uzbek language for texts. So the role of the numeral words classes in the Uzbek language is the classes. So the categories of the great importance for post-tagging and morphological analysis. The proposed post-tagging algorithms is based on rule-based approach and consists of the following stage. Based on the text of and morphological modeling presented above, the overall post-tagging decline in the illustrated figure 1. That take this ambiguation is agglutinative structure. Due to the agglutinative nature of the Uzbek, simple suffixes may occur within a single token. For example, in Uzbek, beştadanları, in such cases, suffix level suffix matching is in issue for accurate post assignment. The tagging system must prioritize suffix heritage of and morphological assignment order. For example, beştadanları for noun plus unit is plus distributing plus plural plus positive. So in morphological complex construction, ambiguity arises from overlapping suffix function and nested grammatical features. Therefore, disambiguation rules of applied reasoning. The following first one, morphological assignment properties, suffix order and constraints, and textual dependency parts. This matches is ensures reliable post-assignment even in multi-layer publicity or forms. Uh, the conclusion of my presentation, grammatical post-tagging is an important task is field of natural language processing, which allow for automatic analysis of language by identifying the grammatical role of word. So the level in process of grammatical leveling adjectives is important to determine the morphological features of the word, including their translation to temporal or superlative degrees, leading to fix as well as the relationship between adjectives and nouns. And the level of adjectives, their contextual and semantic features play an important role in insurance accuracy the post-tagging process. Correctly identifying adjectives in the ordering level affixes is in the comparative level and intense theories used in the superlative level reduce error in language analysis and increase the efficiency of the system. Correctly disambiguation level of adjectives during the study allows us to fully reflects the complex grammatical structure of the Uzbek language. Analyze the internal division of the number of words class in the Uzbek morphological and semantical by dividing into ordinal, distributional, range, functional, and summative types according to non-type version. For each type has its own suffix structure. For example, Uzbek language, inti, ninti, tadan, tata, all in etc. The suffix helps to clearly distinguish in post-tagging. So the Francis, thank you for attention.
Okay, nice presentation. No question. Call to the next.
Thank you.
Okay, sir. So next we have with us K.S. Shubham to present his work titled as Haze to Vision Pipeline for Underwater Image Restoration, Enhancement and Object Detection. Shubham, are you present?
Yes, ma'am, I am present.
Yes, so you can start presenting.
Oh,
Please try to complete it within 8 to 9 minutes.
oh.
Yeah.
All are requested, just 1 minute. All are requested. Please focus on your contribution. Okay, no need to read the slide. What is your contribution? What you have achieved? Just try to focus on that part only.
Can you see my slides?
Yes, it is
Yes.
visible.
Go ahead.
Okay, this is K. Shubham, Assistant Professor from the Department of Electronics and Communication, KLE Technological University. My title of the paper is Haze to Vision, Pipeline for Underwater Image Restoration, Enhancement and Object Detection. So I will begin with the introduction part and motivation part. Here you can see the three images. So what exactly underwater images is? Underwater images will be suffering from the haze color distortions. So here you can see that three images, and first one it is a blue tint, and second one it is a green tint, and third one is it is enhanced image. So what happens is whenever the ray of the light like falls on the sea or ocean, so higher the wavelength will be observed first, then the lower the wavelength will be observed next. So due to what happens, like the lower wavelength of the light will be bluish. That bluish color will be it appears on the images. It appears on the images, as well as you can see that second image, it is a quite greenish. So this is happens because of the flora present in the underwear. So actually what we have done is we have we have tried to restore the image. Once after restoration of the images, we have enhanced the image. We have done the color corrections to the images. Then after that, we try to detect the objects in that image. So that is what we have thought, and that is what we have done for our uh, for paper. So here, this is very important for the marine exploration. Marine in sense like flora and fauna, both the exploration, and it is a very vital and important to understand the marine creatures. Second, Second one is the research gap and objectives. So what I have observed is many of the people have started like they have worked many of the things like they have worked specifically on the restoration where they have done the color correlations, uh, color corrections they have done, and some of the people have worked on the enhancement part, and some of the people have worked on the object detection part. But what I found is there is no complete pipeline where it is going to restore, enhance, and detect the objects. So that is why I come up with this thought that so that we can develop a pipeline where in which a restoration takes place, enhancement takes place, and detection of the object takes place. With respect to that, we have defined the objects. In this, we have defined three objects. A very fundamental objective was that is restoration, and second one is enhancement, and third one is the object detections. And after that, demonstration of that complete model and finding the quality matrix and representing the output. Now, this is the proposed pipeline. In this pipeline, you can see that at initial we are giving the image, which is a noisy image, and when you see at the output, our image is completely enhanced, as well as you can detect the object inside that image. To get this image identification, what we have done is we have gone through all these three models. The very fundamental model is the restoration model, and second model is GAN cell supervised model. We have named it as enhancement framework. Then after that, we have used the object detection model. So we'll go through one by one. At the very fundamental and very first one, yes, the very first model is restoration model. In this restoration model, what we have done is we have taken the autoencoder. In this autoencoder, what I have done is I have taken the some around 5,000, 2,000 of data sets. Around we have total 20,000 of data sets. In that, around 2,000 of data sets I have taken. For that, I have introduced the patch noises. I have introduced the patch noises. Once after that, what I have taken autoencoder. In that autoencoder, I have given my inputs as the patchy noise images. Okay, so in autoencoder, what happens is there are two methods. One is encoder path and another is decoder path. In encoder path, compression of the image takes place. Compression of the image takes place at the bottleneck. Compression takes place from 256 into 256 into 3 to 32 into 32 into 8. Where in bottleneck, what happens is a salient features, a very important vital features will be observed and it will be taken, will be considered. From that, it will be again recompression takes place. Again, it will be decoded. Again, it will be decoded back to 256 into 256 into 3. So when we have done this, we got the very good result. And so during this process, we have used the MSC loss, and we also find out the PSNR. So MSC is what it is. It is predicted minus actual values, and MSC is PSNR values we find with respect to the reconstructed and input given to the model. Then after this, Okay, so this is the output of the model. You can see here the very fundamental. We have taken this noisy images and we have introduced some patchy, and this is the output of the images where we have taken around 2000 images and we have trained the model for 500 epochs, and we have found out this is the output of our model, and we find some PSNR metrics for this. After this, this is the restoration model. Next, we'll be going to the enhancement model. Okay, yes, this is the enhancement framework. This is the second model. This is the second model. In enhancement framework, what we have done is we have taken the grand model. We have taken the generative adversarial network model, where there are two parts in the generative adversarial networks. One is a generator model and another is discriminator model. So we have fed high resolution data set to the discriminator model and low resolution images to the generator model. So while giving low resolution data to the generated model, we have extracted the feature from VGG 19. Okay, from that too, we have fed it to the generated model. Whereas here in discriminator model, we have taken the residual networks. Okay, so why we have taken is in order to extract the best features in discriminator as in generator as well as the discriminator, so that the whenever we do the discriminator loss, generator loss, and adversarial networks loss. Okay, yeah, these are the different loss equations we have used for our the model. So first, very
Shubham,
fundamental, we have done the hello.
just a
Can you hear me?
reminder. Yes, we can hear you. Just a reminder, please be crisp and on point. Wrap up within 1 to 2 minutes.
Okay, ma'am.
Yes.
So, so here we have the discriminator loss, adversarial loss, content loss, perception loss, and total loss. So what exactly happens is discriminator loss is with respect to the how discriminator is a discriminator loss is compared with the generator loss. Then after that, adversarial loss is like it is a competition between the generator and the discriminator. So generator try to fool the discriminator. So that is what the comparison will be observed in the adversarial loss. And the content loss is the with respect to the generated images, how the content of generated images is lacking from the high resolution images that will be observed in the content loss. And perceptual loss is what? In perceptual loss is whenever the VGG 19 or any pre-trained model feature is extracted, how exactly the images content loss or any losses happened, that loss will be calculated by the perceptual loss. So total loss we have calculated as content loss, perceptual loss, adversarial loss. So this is observed, and with respect to that, enhancement model is designed and developed. Yeah, this is the output of the model. This is the output of the enhancement model. Here you can see that two of the images we have taken. And the first part is the noisy images, and second part is the enhanced images. Okay, so we have used the workstation for that, and we got around. So we have taken for enhancement model, we have taken around 10,000, like 20,000 of data sets we have taken, and 10,000 of epochs we have used for that, which with the patch size of 8. And we also found out the SSIM and UCIQ, UIQ we have done, and we got the very good results with 38.33 and UCIQ 0.81 and similarity index of 0.7. Okay, now this is the object detection model. This is the third model which we have used for the model. Once after restoration enhancement, we have fed the model to the we have fed that output of those model to the object detection model. Here you can see that when you like
So then
object is detected.
go to the
Hello.
final result. Go to the final result. We are in
Oh,
short of time.
oh,
Go
oh,
to the
oh.
final result.
Okay, okay. This is the output of the model, and these are the different confusion matrix PR curve, and these are the like loss and training loss and validation loss and choreogram. And this is the proposed like matrices. PSNR 38 point, SSIM 0.6, UCIQ 0.81, UIQ is 0.0, and this is the conclusion part of this our project. So what exactly we have developed is proposed the model where we have restoration, enhancement, and object detection incident. We got the UCK vacuum. And what is the feature scope of this is you can use a clip or blip model for the LLM to image capitalizations. That can be done as the feature work. And thank you. And if you have any questions, I can take.
Okay, you mentioned that one 10,000 epochs. If we are going
Yes.
to increase the epochs, is there any changes in result or result is remain same?
Yes, we have used 10,000 epochs for the enhancement model.
Yeah.
Like after the 10,000 epochs, like around like 9,000 to 10,000 epochs, we almost got the same result. There is no need of more reading to that. So there is no any changes like after the 10,000. So
Okay,
that's
it
why
is
we
remain
stop.
constant. It is
Yes,
remain same.
it's
Okay,
remain
good.
constant. So,
Okay,
and
okay.
yes,
Okay.
any
Next
other questions?
presentation.
Oh,
Ishita, hand over to you.
Yes,
thank
sir.
you.
So our next presenter is Fatema Zahra to present her work titled as Moderating Effects of E-Consultation Training on Sustainable M-Health Adoption Among Physicians. So Fatema, are you ready?
Yes, let me share my screen.
Yes.
Am I audible?
Yes, you're audible.
Can you see my screen?
Yes, it is visible.
So, hello everyone. I'm honored to be here today. Today I will present our research titled Moderating Effects of E-Consultation Training on Sustainable M-Health Adoption Among Physicians. So, we conducted this study to address a critical bottleneck in digital health, that is the inconsistent long-term adoption of platforms by medical practitioners in a developing country like Bangladesh. So mHealth platforms are not just a convenience in a country like Bangladesh. They are a lifeline with a population of over 170 million. There are health disparities and physician shortages. For that, there are platforms, but despite initial adoption after the post-pandemic era, there has been inconsistent and declining use by physicians. So this remains a stubborn challenge. So doctors sign up, use the platform for a while, and then drop off. And the result is suboptimal resources, unmet patient demand, and lost potential. So here's what's interesting is that most existing research has focused on the patient side of adoption. We know what makes patients willing to use such platforms, but the physician's perspective, particular around sustained long-term use, is understudied. So this gap shaped three of our three research questions, which we can see. Uh, those are which theoretical lens best explains doctors' continuous intention to use these platforms. The second research question is that to what extent do factors like patient engagement, digital literacy, trust, system quality, social influence contribute to doctor satisfaction and continued use, and critically, does training on virtual consultation skills moderate the link between satisfaction and continuous uses? So, to answer these questions, we have done the following research. So, this is our conceptual framework. We have used three established models, which are expectation confirmation model, Dillon and MacLean IS success model, and with the UTOUT 2 model. So, the expectation confirmation model actually posits that satisfaction derived from confirmation of pre-users' expectations is the primary driver of continued system use. And this is more appropriate for our context, which focuses on initial adoption. We enrich this with constructs from Utah 2, which contributes social influence and relative advantage, and from Dillon and MacLean IS success model, which contributes system quality and trust in technology. So this is an important theoretical contribution. So we accommodated and integrated the expectation confirmation model and Dillon MacLean IS success model with UTOUT. We have also integrated patient engagement relative advantage, and training on virtual consultation. So these factors in technology adoption framework for disruptive technologies in healthcare sector are rare, and rarely these factors have been explored in academic work on exploring these factors. So from this integrated framework, we derived our hypothesis. So firstly, we propose that digital literacy and regulatory clarity positively influences satisfaction. So this means that a digitally confident doctor that who can navigate the platform smoothly or reduces friction, or if we say if there are clear legal frameworks around data privacy, it reduces the anxiety and finally acts as adoption facilitators. Next, we have propose that patient engagement directly drives continuous users intention. This means that an engaged patient makes virtual consultations feel more worthwhile and professionally rewarding. And similarly, patient engagement positively influences satisfaction. So continuing our framework, we propose that relative advantage and social influence, that is the endorsement from peers and institutions, are primary predictors of satisfaction. We also looked into system quality and trust. So physicians need to know that this technology is won't jeopardize care quality or data safety. And the next proposed hypothesis is that training directly improves the continuous user's intention. That means the doctors who receive simulation-based training on virtual consultations reports higher self-efficacy and a stronger intent to continue. And then we propose that satisfaction leads to continuous user's intention, which is consistent with the ECM's, that is expectation confirmation model's core premise. And finally, our hypothesis 10 is our core contribution. That is, we hypothesize that training on virtual consultation skills significantly moderates the path from satisfaction to long-term users. So this means that when a doctor is trained, their satisfaction converts more powerfully into long-term commitment. This moderating role of training had not been empirically tested before in this context, making it the theoretical highlight of our study. So for our methodology, we adopted a quantitative cross-sectional design. Our population involved registered medical doctors in Bangladesh holding MBBS or higher qualification, and we collected 898 valid responses. The sampling was non-probability purposive sampling. This means that we targeted doctors who already has hands-on health experience, and as a result, this ensured that our data is meaningful and not diluted by those who have never used these platforms. Then our instrument used a 6-point Likert scale, deliberately avoiding a neutral midpoint to encourage definitive responses. And all this analysis was conducted using Smart PLS, using the two-step PLS SEM approach, first validating the measurement model and then testing the structural model. So before testing our hypothesis, we ensured the reliability of our data. As we can see that all our constructs from digital literacy to trust and continuous users met the threshold criteria. Cronbach's alpha and composite reliability scores were well above the required levels, and our average variance extracted values confirmed strong convergent validity. And essentially our instrument was both stable and accurate, but I want to note some small nuances. We can see that the regulatory quality showed slightly lower Cronbach's alpha at 0.598, but its composite reliability and average variance extracted were strong. So this indicates the construct is valid as a latent variable. So this is our the result that we got from Smart PLS. The results were compelling. We can see that our model explained over 50%, that is, to be exact, 51.5% of the variance on both satisfaction and continuous users intention. And 9 out of 10 hypotheses were supported. where social influence was the strongest predictor of satisfaction. Even but we can see that patient engagement did not significantly predict satisfaction. But patient engagement has a massive direct effect on continuous users. So this is a meaningful finding that it suggests that in this context, engagement and satisfaction are distinct phenomena. So, this means that an engaged patient interaction does not automatically translate to a doctor feeling satisfied with the platform overall. And finally, most uh, uh, our hypothesis 10 was also supported, the interaction between training and satisfaction, proving that training reinforces the satisfaction to loyalty loop. Then let me crystallize on what this means in practice for four different stakeholders. So first, for healthcare admins, leveraging social networks among doctors is key. That means that building peer networks and professional endorsement programs. When colleagues champion mHealth, other doctors also follow. Second, platform developers must invest relentlessly in system reliability and security and intuitive friendly designs. So that is how trust is actually earned through every interaction with the user interface. And then policymakers must provide regulatory clarity to reduce the physician's fear, or what should I say, apprehension. And then finally, our study makes a case for mandating simulation-based training. So satisfaction alone isn't enough to keep a doctor on a platform. They need the specific skills to feel competent in a virtual environment. So to conclude, we have validated an integrative model that proves sustainable mHealth adoption requires more than just a good software. It requires supportive social ecosystem, clear legal protection, and critically specialized training. By addressing these factors, we can move from temporary pandemic era adoption to a permanent digital-first healthcare future. So these are the references that we used, and that was it. Thank you for your time, and I look forward to your questions.
Fatima, no question from my side. Very nice presentation. Only one thing is that, as a suggestion, please refer the recent papers for the same work. Lots of work has been done. Okay?
Yes, sir.
Yeah.
Sure.
Ishita, hand over to you.
Yes, so the next presenter is Vemuri Bharat Kumar. Are you present in the meeting?
Hello. Hello, can you hear me?
Yes, so he is here to present his work titled as Quantum Enhanced Healthcare Data Augmentation, a three-pillar framework integrating QRNG, statistical AI, and generative AI for clinical data synthesis. So, are you ready?
Yeah.
Yeah, so I'll stop sharing. You can go ahead. Please be on point, everybody. You have to make it short.
Can you see my screen? Is the
Yes,
screen
yes.
visible? Yeah, good morning, everyone. This is Vemuri Bharat Kumar. I'm here to present a paper on quantum enhanced healthcare data augmentation, a three-pillar architecture integrating QOGR, statistical AI, and generative AI for clinical data synthesis. About me, at present, I'm a research scholar at ICTIS in the School of Data Science. My co-author and guide for this paper is Professor G. Anjan Babu from Department of Computer Science, Tirupati, India. So this is the agenda for us. Today, I'm going to give the brief outline of the entire paper in the time of constraints. So we all know that, well, let's dive into the introduction. We know that machine learning and deep learning technologies are revolutionizing the healthcare industry. But these machine learning models are completely dependent upon the data which on it trained. So that is one of the primary constraints. So if the data is good, the model performance might be good. And one of the most important constraints we have in healthcare industry is the scarcity of data. That means we have, for example, when the data or the disease is very rare, or we have very small data points in the data set. So what is the standardized way to deal with it? The thing is, we augment the data set, the data augmentation. So data augmentation is generally creating and synthesizing new data points, taking inspiration from the existing data points. But traditionally, we use normal pseudo-number generation. But in our paper, we are combining different technologies like quantum computing principles or quantum mechanics with generative AI and stats things. And what are the problems that actually the healthcare practitioners or clinical researchers are facing? The first one is data scarcity, and the second one is the impact of this scarce data on the machine learning and rule generalization things. And this clinical data scientist couldn't able to understand why or this model is performing in a particular area. So the objective is to prove a concept that we can bring different technologies like quantum principles, stats, and generative AI to build a simple tool which can augment data by generating true randomness. So when going back to the literature review, we found that the standard techniques like SMORT will introduce, we need a lot of computing powers to train the data and get the synthetic data. And 1 minute. Synthetic data. Hello? Hello, is my voice audible?
Yes, it is audible.
Yeah, sorry. There's a small technical issue. The generative AIs and the role of these large language models to explaining the clinicians how this works is also a little bit low. But now at present, it's going. Hello?
But sir, just go to your contribution.
Yes, sir. Sure. That will be jumped.
We are really, I'm sorry, we have a short time. Just go to the contributions.
Yeah, I agree, sir. So here what we are building is we are bringing technologies like quantum principles, that is superposition and entanglement. So superposition is a state where one single particle can exist in two different states. And entanglement is another state where two different particles are completely entangled, and one motion of the other particle is completely directs the motion of other particle. So by using this state, we are generating two qubits. Instead of classical bits, we are generating these qubits. And we are measuring the state. Once the state is measured, this particles drop down and bring to the quantum states, the normal qubit states. And then we are adding this to the distribution. But this distribution is turned into the accessible thing using max Muller distribution, where we know that most of the medical data, the features may be in a normal distribution. So we are trending to bring this into the normal distribution, the data points. And we have the medical constraints. So it's not about generating the data, but it is also about that bringing this data into the medical constraints. For example, pregnancy cannot be a negative thing, and age cannot be about 200. So we are formulated in such a way that these constraints are bring into a particular range of the medical data, but these constraints are dependent upon the clinician or the medical researcher. But the third most contribution is bringing up generative AI. This entire architecture was fed into this Gemini 2.4 Flash API model, and this will generate the clinical overview, whether the data is augmented or not, whether the data is augmented according to the principles of the clinician, and whether the data is ready or not. So this is how the summary reads. And it's a system architecture giving the three different, the different layers of the processing. And these are the technologies, and these are the results. We can able to successfully augment the data using the quantum and principles. Initially, the data set was 768 rows, and we could able to increase the capacity to 998, and all the data points are completely to the medical constraints, and that's all. And we experimented this quantum augmented data sets with the traditional algorithms like logistic regression, and these algorithms, this augmented data, or that is performing actually quite good compared to this our normal technical data things. That classical data augmentation. And we also formulated and developed one user interface like this, where the clinician can upload the data. So here they upload, it will get the preview, then we can use the quantum ranges and the augmentation things. And this is the final final report. And these are some of the references. And thank you.
Okay, no question. Next.
Okay, so our next presenter is Miss Sandhya Aute. Are you there in the meeting? Let me
Yes, ma'am,
check.
I'm there in the meeting.
Okay, so are you ready with the presentation?
Yes, ma'am.
You can start. You have to finish it quickly, just summarize the problem statement, the methodology, and the conclusion. Just that, okay?
Yes. Good afternoon, all. Uh, my paper is about literature review. I have not yet made any, I have not actually finalized my methodology. So, my paper is on early detection of keratoconus. So, just I will give an idea of what is keratoconus. On my left hand side, you can see a normal cornea, wherein you see that the iris is a normal iris. But in keratoconus, what happens is that the thinning of the outermost layer happens due to pressure, and then it starts bulging out. So this is called as keratoconus, and we have by going through various papers, I found that these symptoms are not easily visible, and when patients find that some of the symptoms like rubbing of eye or irritation to sun rays and something like that, then they go to the doctors, and sometimes the doctors, when they use their manual instruments to identify whether they have any issues with the eye, they do not segregate, or they do not classify them into various categories as to how much damage has been done. They just categorize it as maybe two categories, that is a normal eye and a keratoconus eye. So my intention here is to ensure that we find out at a very early stage whether a patient is having keratoconus, because this is identified in teens, mostly in teens with age of maybe from 15 to 20 years. And we know that this is a very crucial age, so we need to take care. Eye is a important organ of a human being. So I have gone through various papers, out of which I have just segregated few papers for my presentation. So, in the first few papers, we found that researchers, they have worked on various parameters. Some instruments that have been used are the pentacam. Then we have the tomographic and biomechanical parameters, which are very crucial in identifying the disease. But then there is very less usage, or sometimes they have used machine learning and deep learning technologies, but they have not collaborated much, or they have not collaborated with the medical team to use this as a instrument wherein you can easily identify the crucial symptoms or very critical symptoms at an early stage, and give some remedies to keratoconus. So I will directly skip to my research gaps. So, from the various papers that I have gone through, I found some limitations in those papers, which I wish to overcome in my research work. So, the first, as I mentioned earlier, that the first very most important research gap or limitation is that they give emphasis only on advanced keratoconus, but they do not mention whether it is subclinical or whether it is moderate, which is very important to identify. The next is adequate integration of tomographic and biomechanical features. So these usage of pentagram and Corvis ST, they are used as complements, but they are not integrated with modern technologies like machine learning and deep learning. So with the integration of these pentagrams, or we can say tomographic and biomechanical Corvis ST with machine learning and deep learning technologies, it becomes easy to get the images, and then after scanning of the images, we can make use of various CNN models and some machine learning models like SVM and random forest to categorize easily, and we can say that we can categorize them into not just binary classification but a multi-class classification. Then some papers they have made use of ensemble learning, but they have not gone very deep into it. So these limitations I wish to overcome in my work. Then next is poor identification of borderline and suspect cases. If there is just a borderline case, they are mentioned as we can say that it is a keratoconus, but it is not segregated as different categories, because every patient with a different category will have a different treatment. So this is not done or this is not seen in the previous papers. Next is a lack of longitudinal analysis. So most of the data that I have seen is localized data. There is no integration of global data. So if this local data, when we work on the local data and when we try to integrate it on a mass or on a global point, there are a lot of variations. So I'm working with some hospitals to find out if I can merge their history or historical data and then come to a conclusion wherein longitudinal analysis can be done. Then limited translation of clinical decision support systems. So when practitioners or clinical staff they take the readings of the patients with their instruments, but then there is no integration with our decision support system. So if we work hand in hand with the clinical staff and then devise a system with the help of AI, it will become more easier to identify this problem at an early stage and give proper treatment to the patients. So with this I come to the conclusion that integrating the clinical data with advanced tools of machine learning and deep learning will help us to ease the work of the clinical staff and also identify the critical cases or maybe the borderline suspect cases easily. So I have researched about 60 papers, and with this, I come to my conclusion. Thank you.
Okay, so do you have any questions for her? Okay, I think there are no questions.
Okay,
So we
ma'am.
will move forward. And we have P. Siva Perumal. Are you there in the meeting? Let me check.
Hello.
Yes.
Actually, Dr. Supermol has gone for some works, so
Okay.
I'm going to present on
Okay,
behalf.
sure. So his co-author will be presenting on behalf of him, and he is here to present a paper titled as Solar-Powered Drones with an Innovative Range Scoring System. So yes, you can share your screen first.
Mhm. Is my screen visible now?
Yes, it is visible. You can continue.
Mm. Good morning, one and all present in the panel. I'm Naresh, and I'm going to present a project titled Solar Powered Drones with an Innovative Range Scoring System. The primary focus of our project is to develop an intelligent and autonomous range scoring system using a drone technology. In modern applications such as defense and industrial testing, accurate range scoring system and evaluation systems are extremely important. But however, the existing systems are mostly dependent on manual or sensor-based operations or like a tower systems which is integrated with sensors. These systems reduce accuracy and increase the operational cost, and it is not reliable solution. Mm, Our solution proposed the drones to be used for the solution. But drones also face some major limitations such as short flight duration due to battery limitations, So on improving these problem statements, our project mainly focuses on improving solar intelligence while using solar energy to support longer missions using the drone. The core problem we address the lack of an efficient and automated range scoring system. The proposed solutions to solve this problem, we propose a drone-based autonomous range scoring system. The key idea is when the drone captures the real-time data at the impact location, and then it processes the data using the sensors and with some autonomous operations using the sensors after the impact and automatically generates a performance score. This performance score will be transferred to the control system in real time. The scoring system evaluates accuracy, detection confidence, positional accuracy, and system efficiency. To support continuous operation, we integrate solar panels with which help extend flight time and reduce dependency on batteries. Let's go to system architecture. These are the papers we refer for the literature reviews and surveys. System architecture design. The main component of our solar project is the solar panels, which harvest energy and support the longer missions during the flight. These solar panels charge the battery in real time, so it increases the flight duration. And the next important system in our project is MPPT, the maximum power point tracking. This ensures that the maximum of solar panel energy is converted into charge to the battery, so that we increase the efficiency while minimizing the loss from the solar panels. So we can charge the battery efficiently as the drone in the real time. Then we are using a new type of technology in battery instead of the regular lithium ion batteries. It's a silicon carbide technology. Instead of lithium ion, it's traditional lithium ion batteries. These silicon carbide batteries have a higher energy density while have a less weight and more number of charge cycles, and it contributes to more efficiency during the power supply to the drone. Then comes the power distribution unit and comes the range scoring flight algorithm. This algorithm calculates the score based on a mathematical formula and the impact. This algorithm compares the impact with the formula and generates a score. This score is then transfers to the control system. Control system and to sensors and data processing unit. It's a based on feedback system. Let's go to product design. This is a flight control system we designed in the MATLAB. This consists of sensors and image data, image processing system, and flight control system. And this is a sensor module which will calculate the score based on the algorithm. It states it points on the states of the variables and it's the environmental variables in the environment of the drone. This is the camera output and this is the sensor output from the drone. Combining these outputs, we are calculating the scores. This is a motor control model. It's also same designed in the MATLAB. This is a communication interface within the solar powered drones. So this ensures that every system in the drone works perfectly. And this is a flow chart. This flow chart explains the complete operation of our drone. Here we just hovering the drone before the attack. And the sensor sense the area, and then the image is converted to the grid coordinates to analyze the impact. Then the sensors calculate the impact at the time of impact, and it calculates the score. The drone checks for the coordinate and the impact coordinate and the normal coordinate to compare the score, and the score is calculated and it's transferred to the control station. We have the product model description and component specifications in this. We have a drone frame. These are the materials used in the drones. Mm, Here is some battery specifications. It's silicon carbide. Mm, These are the simulation results we obtained in the MATLAB system. It is an MPPT model of the MPPT model designed in the MATLAB. So it maximizes the efficiency of the solar panel so that we can charge the battery efficiently with the minimal loss. And this also increases the efficiency of the panel. This is the output of the MPPT. As we can see, the solar output of the panel is very minimal at the starting of time, and over the time it improves the efficiency of the panel, and we can get the maximum power output from the panel by using this MPPT module. This is also the same waveform with an elongated. And these are the simulation results we obtained by our ML algorithms by cleaning the situations based on our drones. For this, we have created our own data sets because this project currently don't exist in real life. So we made our own data sets to train this model. And this is the simulation results. This is a range score versus impact distance plot. In this, the impact distance from the target is calculated against the range score. This is MPPT efficiency plots. Based on the environmental situations, the solar panels output will be differs on the environmental parameters as well. As it is a defense application, we ensure that this drone operates in every possible environmental situation, and worst environmental situation. This is sim battery plots, the battery discharge over time, and the solar energy capture versus the time of the day. During the different time of the day, we run the simulation on the different point of the day to capture the max performance of the MPPT and the solar panels. These are the prototype results. We have made a just prototype of range scoring system to and implemented it in the ML model to run the system. This system actively tracks for an impact in the location, and when an impact occurs, it will generate a score based on the calculations and pre-processing models. These are the experimental results from our ML model that has transferred from the drone to the control system. This is the data set we created for our drones to train our ML models. For this, we used multiple AI models to create this experimental data sets so that we can train our ML models. These are also experimental results. Future steps. On the future steps of this drone, we can improve the solar efficiency as we can.
Naresh, okay, understood. You've shown the data set.
Yes, sir.
What is the size of data set and which parameters are there?
The size of the data, it is a 10,000 parameter data set, sir. It covers the impact distance, accuracy, and this is a third product score, sir.
What is the name of that column? First column 2.1.75. What is the name? What kind of the values there? Which values are there?
Yes, sir. This plot consists of an impact accuracy. This mathematical model consists of based on the formula we created this data set, sir.
What about the last column 99.72, 69?
It is a final score we obtained from the model, but it exceeds
You're
100.
supposed to add this
Yes,
column
sir.
name is not, column names are not display.
Yes, sir, but it cutted. The image is little bit small, sir.
Okay, okay. You can conclude
Okay, sir.
within 1 second.
Mm. Our project mainly focused on developing an intelligent and automated rain scoring system using drone technology. This integration of solar energy acts as a supporting feature to improve endurance and efficiency. This makes the system accurate, autonomous, and sustainable. Thank you for the opportunity.
Okay, thank you. Nice
Okay,
presentation.
thank you so much. So next
Ishita
we
ma'am,
have,
Ishita ma'am,
yes,
how many presentations are remaining?
let me check. So, okay, so this and two more presentation will be there. So total three presentations are remaining.
Okay. I request all the author, please target the your contribution. Once again, I am really sorry. We don't have much time. Okay.
Yes,
I have next schedule. So please target just within 3 minutes. I'm going to allow you. Just focus on your contribution.
okay, so next we have Chalani Dinitha. Are you present in the meeting?
Yeah, ma'am.
Yeah, so you can start presenting and be quick.
Okay. Can I see my screen?
Yes, it is visible. You can start.
Okay. So, hi everyone. So, I'm Shalini Dinita, and today I'm presenting our survey title Survey of Hallucination in Large Language Models Detection, Mitigation, and the Future Direction. So, which I wrote on with my co author Saad Jawad, and we are from the Informatic Institute of Technology in Colombo, Sri Lanka. So, basically, I will directly go with the my taxonomy part. Wait. So first I will explain what is the hallucination, right? So in simple terms, hallucination is when the model generate text that sound fluent and convincing, but is not based on the real facts or a given output. So one important thing is that the model often gives these wrong answers with high confidence, which make them difficult to detect. For example, it might say Marie Curie discovered the penicillin, so which is exactly wrong, right? So these are not just a normal mistake. They happen because the model predict the word based on the probabilities, not actually understand. So then I will directly go with my taxonomy part. So in the taxonomy, in our survey, hallucination are mainly divided into two categories: factuality hallucination and the faithfulness hallucination. So first, factuality hallucination. So this one is happen when the model give information that is incorrect according to the real world knowledge, right? And we can divide it into two parts: factuality contradiction and the factuality fabrication. So factuality contradiction is this is the when the model is give the clearly wrong facts. For example, it may assign wrong person or wrong relationship, something like that. And the factuality fabrication means this is when the model create completely new or false information that does not exist. And we can then divide it into the unverifiability and the overclaim. So in the unverifiability, the information cannot be found or checked anywhere, right? And then overclaim, actually, it is like excreting or adding achievements that are not real. So, for example, saying someone won award they never received, something like that. So then I go with the faithfulness hallucination. So this happen when the model does not follow the user's input or instruction or a context, even when the information itself might be correct. Then we can divide it into we divided it into instruction inconsistency and the context inconsistency and the logical inconsistency. So instruction inconsistencies, this is when the model ignore the instruction given by the user. As example, if the user asks for a it means like sentence answer, but the model give the long paragraph, so the model fail to follow the task, right? So in the context inconsistency is this happens when the response is not relevant to the given input or a topic. And then finally the logical inconsistency is like
Ma'am,
this is
go to your contribution.
yeah, okay, wait. So then I will go with the contribution part. So these are the existing detection methods I found, and so I will go with directly future detection, and then I will go with the contribution part. So in this future detection, I actually I when I do the review paper, so I found these gaps in this hallucination detection in LLM domain part. So now let's look at the future detections. So first, fine gain detection. It's like instead of making the whole answer wrong, we want to identify the exact incorrect word or a phrase, right? So that's the first one, and the second one is improving the long it means like long from accuracy, because error increase in the longer response, right? And then third, I find this one, better understanding of the hidden state to detect the hallucination earlier. And finally, actually the it's hallucination in multimodal system like image plus text, something like that, and multilingual settings, so especially in the low resource languages. So these are the important area of for the future works. And then I will go with the our contribution of this review paper. So on this slide, I would like to highlight the specific contributions of our survey. First, we provide a comprehensive taxonomy that clearly distinguishes between the errors involving real world facts and error involving the user's specific instruction. And then second, we didn't like just look at the symptoms, we analyzed the contributing facts at the every stage, right, from the training data to the final inference. So the third one is we conduct the slide by slide comprehension of current detection framework, and looking for the both internal model signals and the external fact checking methods. And finally, our work like identify the critical future direction, especially calling for the more inclusive research into the multimodal system and low resource languages to ensure that the benefit of the safe AI reach anyone. So then I will go with the conclusion parts. So basically, as a conclusion, the hallucination is one of the biggest challenge in the making AI system trustworthy. So even through there are many detection and mitigation methods like uncertainty analysis, internal monitoring, and the fact checking. None of them are fully solved problem yet. So like these days, I'm doing some. Actually, I am found some gaps, right? Gaps. Then I'm like combining the hidden state and the fine gain one, and then like I'm planning to do a research for that part also. Yeah, thank you for the giving chance.
Okay, sir, any
Okay,
questions
thank
from
you.
your?
No question. Next.
Okay, so next we have Mr. Shojhakhon Damov. Are you present in the meeting?
Can you hear me?
Yes.
Unfortunately, Shahjahan Kamadamov couldn't attend today's conference due to reasons, so I'm co-author and I will present his presentation.
Okay, so she is here to present her paper titled Artificial Intelligence in Migration Management Opportunities, Challenges, and Policy Implications. So you can start your presentation and be quick, please.
Okay.
Yeah.
Is it visible?
No, not yet. Try to reshare the screen.
Is it visible now or no?
No. Yes, it is visible now. You can start. You are not audible, miss. Could you please resolve? Okay. I think we should move on to the next presentation till the issue is solved.
There are some issues I cannot.
Yeah, it is visible. The screen is visible.
And my voice is. Can you hear
Yes,
my voice too?
yes,
Ishita
we can
ma'am,
hear you.
if there is a technical issue, then just tell her to discuss the contribution.
Yeah, so
Okay.
you can just summarize your paper in quick 2 to 3 minutes.
Okay.
Yeah.
The increasing scale and complexity of global migration flows have created significant challenges for traditional migration management systems, particularly in terms of efficiency, data processing, and timely decision making. Recent advances in artificial intelligence offer new opportunities to enhance migration governance through intelligent data analysis, automation, and smart communication systems. This paper examines the role of AI in modern migration management with a focus on border control, visa and asylum processing, migration flow forecasting, and migrant intelligence services. So,
That's it? You are done?
no, I would like
Okay.
to make methodology too. The growing complexity of global migration has stimulated extensive research on digital and intelligent solutions for migration governance. Early studied on migration management primarily emphasized administrative coordination, border security, and policy harmonization, relying largely on manual data processing and conventional information systems. However, the increasing volume, velocity, and variety of migration-related data have exposed the limitation of traditional governance approaches, leading scholars to explore the role of advanced digital technologies, including artificial intelligence, in migration systems. Can you see my presentation?
No, that's fine if we are not able to see your presentation. Just summarize and conclude.
Okay.
Yeah.
So the there was a table that contains textual analysis highlighting the role of AI-driven system in enhancing border control process through biometric technologies and real-time risk assessment. This slide also includes a conceptual framework diagram illustrating the integration of AI in migration management, supported by various data sources in operational domains. Additionally, a partially visible table outlines AI application, their functions, benefits, and associated governance challenges. So now I would to conclude as time to come to end. In conclusion, artificial intelligence represents a key enabler of smart and sustainable migration governance when embedded with the robust legal, ethical, and institutional frameworks. By aligning technological innovation with principles of transparency, human oversight, and responsible communication, AI can support more efficient, fair, and resilient migration management system in the context of smart digital societies. Thank you for the opportunity. That's all.
Okay, thank you so much. Just just a request to you. Can you put your name in the chat box, please?
Yes, of course.
Yeah. So next we have Rupali Vairagde, ma'am. Are you here, ma'am?
Yeah, ma'am. I'm here. I'm
Yeah.
audible.
Yes, you're audible. You can start presenting. You have to summarize your paper quickly and conclude it within 3 to 4 minutes.
Ma'am, can I request you, ki please you can schedule. I'm busy with one meeting. It
Yeah,
just
you can present in next session. That's fine. It will be
at
starting
what
at
time, ma'am?
1:30.
1:30. So the next
Yeah.
presentation you will not going to be allowed me.
So there's only
It
one
will take
presentation
one.
left.
Only my presentation it will be left.
Yes, so that's why I'm saying that you could present in the next session, please.
No, no. If possible, just a minute. Give me a time. I will share my PPT.
Okay, then we'll take one presentation and then we'll
Yes,
take
yes, yes.
yours. Yours.
Yeah, fine, fine.
So Satyendra Sharma sir.
Yes. Hello. Yes, ready.
Yes, you are supposed to present.
Yes.
Be quick, please summarize it in
Just
short.
a minute.
Yeah.
Now, video on करना पड़ेगा. Now, screen is visible?
Yes.
Okay. Yes. Uh, yeah, good afternoon. I'm Satin Sharma. Today I present an explainable and trustworthy AI framework on liver cancer diagnosis. So, problem statement is that liver cancer is one of the leading causes cancer-related death worldwide. So, because of there is limited annotated and medical imaging data, high variability, and the radiologist interpretations. So there are some problem. So research gap is that mostly existing approach to focus only the classification of accuracy and explainability method are often applied to separately. The trust factor and uncertainty estimation, bias evaluation is there are some research gap which is identified in the data scarcity, interpretability, and clinically reliability. Objective to design a develop a high performance deep learning model system which is explainable, should be explainable. So challenges. This is a core problem area where we are focusing on in this paper. Problem is the data scarcity, which we are solution is I am using the transfer learning and style Gen 2 for the data augmentation purpose, highly computation. I'm using the fish internet before interpolability. For purpose of interpolability, I'm using the great cam and chef. And last, lack of trust just we are using uh, just, hey, just a moment, sorry. My contribution that I'm defining propose a unified AI framework integrated transfer learning, GAN based augmentation, explainable AI, and trust mechanism to achieve improved accuracy, enhance interoperability, and increase the reliability. This system, uh, this is the architecture of key. Just we are taking the input image and then the pre-processing with the CNN model. We can say that then I'm using the advanced CNN model plus CNN, basic plus advanced CNN model, and explainability. The explainability I'm using the grade and chef, uh, grade and chef user, and then then the then the using the this model transfer to the data to the VIT model, And the BIT model we are featuring. After that, the feature function and the classifications. And last is the explainability in which I am using the great cam and the chef, and in the last the trustworthy. This is the basic architecture of this model. Data set, I'm using the LITS data set and some the clinically data set like the tissues or the pathological data. So this is a data set we are taking. I'm taking the 70-15% split the data into three categories: 70 plus 15 plus validation purpose is 15. Accuracy result is a ResNet is a 0.85. Overall result is a 98. Overall, my model is a predict the value around the 98% is they are given. Explainability, highest tumor reason, 89.4 correct localization, SHAP is providing the feature level of importance aligned with the clinical biomarkers. Trustworthiness, uncertainty estimation, 7.3 prediction flag, and bias evaluation, the AUC reduced the 0.01. Advisory robustness is 14% improvement. This is a discussion here. So integrated framework outperform the isolated model, balance performance, interoperability, and the reliability suitable for all real-world clinical application, addresses key limitation AI system. Conclusion, develop a unified AI framework, improve accuracy and trust simulation, demonstrate the clinically applicable. Thank you.
Thank you, sir. Ishita ma'am, call the next paper.
Vairagde ma'am, Rupali Vairagde.
Seven.
Rupali Vairagde ma'am.
Yes, ma'am. Can I give my presentation in 1:30 slot, ma'am? Will it be okay?
Yes, sure. You can
I
do
will
that.
give it in 1:30 slot. I'm having one meeting.
Yeah, sure. You can
This is my
leave.
first presentation at 1:30, no?
Yes.
Okay, thank you.
Yes.
Sorry.
Yeah, that's fine. Okay, so we have come to the end of this session. So I sincerely thank all our authors for their excellent presentations and valuable contributions. And all the participants for being an important part of this session. I truly hope that this session was insightful, engaging, uh, and inspiring for everyone. So, on behalf of the entire team, we thank you for your continued support, not just for this 11th edition, but for all the 10 previous editions of ICTIS. So, we look forward to welcoming you again in the 12th version in 2027. All presenters will be receiving their digital certificates via email within 2 working days. The publication will be live within 7 to 8 months. So we kindly request your cooperation with the ICTIS team 2026. I would also like to extend my sincere thanks to our session chair, Dr. Ganesh Pise sir, for expertly chairing this session. So this is a small token of appreciation on behalf of Team ICTCIS and Global Knowledge Research Foundations and partners. So thank you all once again for your valuable presence. And before we officially wrap up to this session, let's capture this memory. I kindly request everybody to switch on your cameras for a group snapshot of this virtual conference. So 1 second, I'll stop sharing and click a snapshot. Yeah. So everybody is requested to please turn on their cameras. Yeah. Thank you, everyone. Okay, thank you so much, everybody. Stay safe. Thank you so much, Ganesh sir.
Thank you, madam. Thank you. Thank you.
Excuse me, ma'am.
Yes.
Sorry to interrupt.
Yes.
One query where to raise the ticket, ma'am. I actually, our abstract and the website is mismatching.
The publication, when it will be published, it will be correct. Now it is just mismatched.
Okay, ma'am. Thank you.
Yeah. Thank you, everybody. Rupali ma'am will be taking your presentation first in the 1:30 slot.
Yes, ma'am. Yes, I will join.
Yes.
Thank you.
Thank you.
Thank you, everyone. Thank you.